Okay. So what we're going to talk about today is how kind of an application of proportions, which is what we've been doing. So I wanted to start with the warm-up on proportions so that we make sure that we genuinely understand it, because some of you really preferring to not set up your proportion. Remember, your proportion is going to be half of that question. Half of that question is me seeing the proportion. Okay? And I'll tell you why. Because if you set the proportion up wrong, but you do the solving properly, I'm going to give you half credit and you will have gotten it wrong. Does that make sense? So if you set the proportion up wrong, but you do the cross multiplication properly and solve for the one that you set up wrong, I give you half credit because you did the proportional reasoning correctly. You set it up wrong. Okay? So it benefits you to make sure that you're showing your work. If all you show me is a wrong answer, you just get the whole thing wrong. You don't get half credit, you don't get anything. Okay? So make sure that you're giving yourself an opportunity to get that half credit. It says the ratio of width to length of a swimming pool is 5 to 8. Right off the bat, I would go ahead and, oh, I see what they're saying. This. That's a problem. Give it a second. Let's see if it's, oh. No, still not. Give it a second. It's resetting. Okay. Wait, I want to get it so it's. That is going to be problematic. All right. So then I'll do it like this. Here we go. Let's just see what we got. It says the ratio of width to length of a swimming pool is 5 to 8. So we know that 5 to 8 is the ratio that they give us. And they also gave us the order that we need to consider when we are writing that proportion. Now remember, the most important thing about proportions is genuinely the setup. You must make sure that everything corresponds to the right thing. In this case, we're going to end up with width over length on the right side as well. Then it says if the swimming pool is 32 feet long, so where does 32 go?
The bottom.
On the bottom. How wide is it? And now we're good to go. Now, what is always step 1 on solving proportions? Jaden? Perfect. See if you can find an easy way to go from the left to the right using, what do we call that thing? Scale factor. Very good. Is there a scale factor in this instance? There is. The scale factor is 4 times 4 times 4. You should have gotten 20 feet. 20 feet wide. Okay? 20 feet wide. Let's finish this. Okay? Any questions on that? Now, this one it says, as I finish the 8-mile, it says, if I finish the 8-mile race in 1 hour and 16 minutes, what was my minute per mile unit rate? Now, that right off the bat, guys, should give you an indication as to what your proportion is. Remember, every proportion looks like this. It says, what was my minute per mile rate? That's half my proportion. Minute per mile. When you see that per mile, per gallon, per pound, they're giving you how many gallons and pounds and miles it is. It's 1. It's a unit rate. So what goes on the left? Alex, what did you get on the left, please? 76 over 8. Because you have 76 minutes in an hour and 16 minutes. You have 76 minutes in 1 hour and 16 minutes. So now what? What do we do now to solve? Cameron, what did you do to solve this?
I
Cross. Well, you can actually, there is a scale factor, but what's the,
76 divided by 8.
yeah, but here's the problem. If they were to ask you, here's the interesting thing, Andrew, listen up. If they were to ask you to identify the scale factor, it is not 8.
1/8.
It's 1/8. Because you can only use multiplication with scale factors. Okay? So the only way to get from here to here is times 1/8, and that would have to be times 1/8. Now some of you may go, you know what? I'll do fractions, no problem. Some of you may prefer division. It doesn't really matter, you'll get the same answer either way. So let's try the fraction thing. 76 times 1/8, right? Put it over 1, we begin to cross simplify. They're both even right off the bat. Is this divisible by 4, by the way? It is. It is divisible by 4 because it's 4 away from 80, which is divisible by 4. Yeah, so this is 19 because it's 4 away from 80, which makes this 2, which means 19 over 2, which simplifies to 9 and 1/2.
Is 9.5 right?
Well, is 9.5 the same as 9 and 1/2?
Yeah. Do you want us to do one of the others?
Well, that's not what you asked.
Okay. Do you want us to do fractions over?
Doesn't matter.
Doesn't? Okay. You want to
Yeah. The only time that I usually prefer, Christopher, the only time I prefer fractions over decimals is when your decimal is non-repeating, or is, that is non-terminating, goes on forever. So if it was 9 1/3, you could not tell me it's 9.3 with a line over it, because then you can't check to make certain. Okay? I want the exact number. Any questions on that? Very cool. So we're going to go for about 5 or 6 minutes, and then we'll come back and finish it. But I want to start with this similar figure thing. Number one, before we get started, we have to understand, how do we set up and solve a proportion? What's the most important thing to remember when we're setting up our proportion? The time. The units. Making sure that everything matches right. If you have turtles over lizards on the left, you have turtles over lizards on the right. Very important to make sure that it's set up properly. Does anyone know what the word congruent means? Yes. Jason, what does congruent mean? It means exactly the same. Doesn't mean close, it means exactly the same. The only thing congruent to the number 32 is the number 32, basically. Okay?
32 over 1. 64 over 2.
Yeah.
128 over 4.
Yes, that's true. So what does corresponding mean? Have I ever heard the word corresponding? Brendan, what do you think? Why'd you raise your hand?
Sorry, I had water.
I got you. Okay. What's corresponding mean?
Like relate to each other, maybe?
Ooh, very good. Anybody else have another idea about corresponding? Christopher?
The same.
The same? Gavin?
It's COR with responding.
Very good. Thank you, sir. It is corresponding. Jackson.
Maybe that's to do with
Direct response.
What it basically means, go ahead, Alex.
It's if two things are corresponding, then they have something in common.
Really?
That's exactly what it means. It means they have something in common. Now, that figures into what we're going to do today, because we're going to learn about what are called similar figures. We're going to learn about something called similar figures and how it relates to what we're talking about with proportional reasoning. What we first have to understand is that if we have congruent figures, then we have figures, happy, thank you. We have figures that are exactly the same shape and exactly the same size. And part of the reason I put this slide in there is I need you to understand this symbol means,
Corresponding.
it means congruency.
But the 3 lazy lines come out.
It means that it's congruent. If it says triangle UVW is congruent to triangle XYZ, then it's basically telling you that those two triangles have exactly the same length. They're exactly the same size. They have exactly the same areas. They have exactly the same size angles. They have everything is the same.
I think it's be equal.
Do what?
I think it's being equal and not congruent.
Because congruent has mathematical ramifications, which you'll see in a moment that equal does not. Okay? There's a reason we're going there. But you need to understand the congruency symbol. It's basically an equal to sign with a little wavy thing on the top. Wait.
Oh, that's why it's here.
Yeah. 22 with a little wavy dude on top. Okay?
Dad, please.
Okay.
Hate it.
Similar figures. Very important difference. Similar figures have the same shape, but they are not necessarily the same size. And that would be marked by this symbol that you see on the board. Now, similar has very specific mathematical ramifications, which again we'll talk about in just a second.
Does it have to do with the angle? Because the angle is
It has to do with both angles and sides,
the angles are the same.
and areas and everything. Okay? So, shapes can either be congruent, meaning they're exactly the same, or they can be similar. Now, similar, all that's really happening is if in order for something to be similar to me, you can either shrink me down or make me much larger. Okay?
Okay.
Then I would have a similar figure.
Is there anybody with the
I would still be incredibly good looking and smart, but I would just
I can disagree.
That's pushing it.
not push.
I can disagree.
He's just telling the truth. His mother
You know I'm
told him
closing
to lie.
report card days today.
No, these are awesome.
And then giving those behavioral things.
Oh, you're super handsome.
Unsatisfactory.
Man, you're so good.
Bennett Powell is a U. Unsatisfactory.
You're amazing.
Does anybody I hated satisfactory. I just thought it was so kind of big. It's like your parents telling you you're like an okay child.
No, satisfactory kind of reminds me of cakes that don't taste good.
Yeah. It's like hugging your sister. It's like,
Oh no. Wait, I don't have a sister.
I have a
a sister.
Okay. So let's get to the next one now. This is where it gets important. Listen up. This is where it gets important. Corresponding angles. Corresponding angles are angles that are basically in the same place on two different figures. So for example, the angle that corresponds to angle C is angle F.
It's not the same, like the angle.
Yeah. Those are corresponding angles. Those are corresponding angles. And in similar figures, corresponding angles, like Jackson said, are congruent or equal.
But it's not the same size if you take that proportion.
Okay, no, hey, stop, listen. Again, I will say, corresponding angles, if this angle is 28 degrees, go ahead, Tess, then this angle is 28 degrees. Corresponding angles are congruent. No ifs, no but, no buh. They're the same. Corresponding angles in similar figures are exactly the same. Okay? But they have to be in the same position. By the way, side AB corresponds to side DE. Now listen, here's something that's very interesting. I'll talk to Tess when she gets back. You notice when you say corresponding sides, you must give it in the same order. If I say length AB, I would say it is similar to length DE. I would not say ED. I would not reverse the order. If I'm going from the A to the B, then I go from the D to the E.
Can you go from like the B to the A and then the A to the B? Is there any?
Absolutely, you can. Absolutely, you can.
Can you go back to similar figures?
Okay, give me just a second. What's confusing?
Because they're different size triangles, so how are they similar?
I said the angles are congruent. Not the sides, just the angles. Okay, that's a very important difference. The angles are congruent in similar figures. The sides are obviously not because they're smaller and they're larger. But the angles are always the same. And here's why. If you think about it, if you think about a square, guys, if you think about a square, what's the sum of all the angles of a square? All four of them.
Oh,
360 because it's four right angles. So if you add up all the angles inside of a square, you have 360 degrees because it's four right angles.
Same for that.
Oh.
Four right angles.
No, because there's a little.
Stop
Why
talking.
does it have to be 360? Well, if you look at
Listen up.
If the angle goes on farther, then it's the same size as that triangle right there.
Yeah, it is.
So, I mean, the angle doesn't, it's like,
The angle matters, and I'll show you why in just a second. No, so here's what we're going to do. We're going to table this in just a second, but what I do want you to understand is that what we're getting at is that when we have similar figures, they're exactly the same shape, they've just been enlarged or reduced. But the angles remain the same. So the statement that you'll see on test is the corresponding angles of similar figures are blank. What would be the blank? Corresponding angles of similar figures are congruent. Corresponding angles of similar figures are congruent because they're the same. They're not proportional, they're not close to the same, they're not similar, they are identical. According to the proportions that we did.
oh, yeah.
Okay.
I remember that.
Okay, so here's what we'll do. We will table this, I think, if I can find the
I wanted to go back to.
aware of. So, we talked about the fact that if you have similar figures, what do we now know about the angles?
They're congruent.
They're not just congruent, you have to basically say corresponding angles are congruent, which is a really, really important concept because here's what it basically means, guys. If you end up, I'm just going to insert a quick slide. If I tell you that these two triangles are similar, and I give one triangle to you that looks like this, right angle, and I give you the other one that looks like this, and you start to, in your head, begin to find the sides and the angles that are corresponding, it would be a good idea for you to take the one and turn it so that they are oriented the same. Because really, when you think about it, this angle corresponds to this angle. So before you start setting up proportions, which I'm going to show you why proportions are important, or determining which angles correspond to one another, you might want to turn the figure and relabel it. Gavin? You have a question?
No, I'm good.
Okay. So, in these two figures, AB corresponds to XY. Very good. BC, BC corresponds to YZ. And again, make sure that you give them to me in the right order, because I will count them wrong if you don't. Even though you may be talking about the same line segment, I want them in the right order. And angle A to angle X. Now, I want to show you a quick way that and you might see this on like the math test or whatever. Sometimes instead of spelling out angle A, they will give you something like this. That means angle A. Or angle X. Okay, that little angly symbol means angle. Okay, so you may see that on a worksheet or on a test or something like that. KL corresponds to? Good. LM. Angle J. Thank you. Well played. Angle J corresponds to angle H. And angle K. What? Yeah. So, all right. Angle EF. I mean, sorry, EF. Line segment EF. TU. No, it's TU. Remember we talked? Didn't we talk about that? Okay. Texas A&M was the first university of Texas in the state. Yes, thank you. FG corresponds to? Good. Angle H. What? Very good. Angle what? And angle G. Very good. Angle G. Okay. Now, if you look at this. Okay. Oh my gosh, Chris. Here's the funny. Okay. Well done. Now here's the funny thing. At some point, when you get home, This will be a recording. And your parents are going to be sitting there like this. This is what y'all do sometimes. And you can say, yes, this is actually what we do. Devin. That was it. No. Okay. Now, here's the thing. This is where it gets important. We've already learned that if the figures are similar, then the measures of their corresponding angles are congruent or equal. Here's the interesting part. The ratios of the lengths of their corresponding sides are proportional. And that's why we study similar figures with ratios and proportions. The lengths of their sides are proportional. And if they're not proportional, which means like ratios are equal, right? If they're not proportional, then they cannot be similar figures. So watch on this one. It's kind of a, I don't like how large the font is, but you can kind of see. So AB over DE, are those corresponding sides?
No.
Yeah, I think they are. AB over DE, which is 3 over 6, equals, what is AC over DF, which is 5. Now, is that proportional?
No.
How do we find out? Here's the thing, Olivia. How do we test to see if two are proportional? Someone who said yes, tell me how we test it, Cameron.
Do 3 times 10 divided by 6.
Or, no, because we're not finding one. How do we test this?
If we give you 5, then you know you have to simplify it.
You could do that. What else could you do, Ty? You could simplify it all the way down. Or you could, what's the one more way? You could use your brain. That's non-specific. Jackson. Check cross multiplication. If 3 times 10 equals 6 times 5. And they're proportional. Yeah, you could simplify it. Tara?
So to get the fractions, do you do 1 over the other?
Yes. You would, when you set up your proportion, you have to set up corresponding sides. Now, that's something I want to just pause on real quick. You could not do 3 over 6 and set it equal to 8 over 4. You can't go in opposite directions. You cannot go in opposite directions. If you do 3 over 6, if you go left to right, then you have to go left to right when you set up that proportion. But you should be able to do it with any corresponding side. You should be able to do it with any corresponding side. Someone tell me if these are similar, and I want an explanation as to why. Alex?
Yes, because 5 times 3 equals 15, 3 times 3 equals 9, 3 times 3 equals 9.
That's exactly right. You can check scale factor, right?
Yes.
How could you set up a proportion to prove it? How can you set up a proportion, Brendan?
For just one side or all of them?
Well, it doesn't matter. Let's just set up one. Set me up one.
So we could do ST
Give me the
over
numbers.
BW,
Give me
so
the
5
numbers.
over 15,
5 over 15,
and then 3 over 9,
and then 3 over 9.
and then
And yeah,
we
then we.
multiply 15
then we-
by 3.
You had me at hello. So, and then we would simply, you have a bunch of different ways you could check this. You could simplify them both down as fractions. You can just cross multiply your cross products and see if they're equal. There are a bunch of ways to test to see if they are similar. Are those similar?
Yes. They're the exact same numbers. Only the corresponding angles are similar.
Huh. How would we test it? Oh, sorry. Yes, ma'am. Go ahead. Tell me how. How can we test to see if they are similar?
The angle.
Yeah, it is. 9 over
Well-
6 equals 6 over 4.
Yes, it is.
Let's try it.
No, it's 6
Is the same fraction 6 to 9 and 3 to 4.5? Is that the same?
Yes.
No, look.
Yes.
9 to
Watch.
6 and 6 to
Everyone sit and watch. Let's try. Let's set one up. 3, what's its corresponding side? 4.5. And let's set it equal to, pick 2 more corresponding.
96.
6 and, well,
Oh,
6 and 9. Now watch. What's 9 times 3?
18, 27.
27. 6 times 4.5.
6 times 4
It's 27 also. So they are similar. That's exactly right. That's exactly right. Don't just assume you need to jump into the math. The way that you determine if they are similar is you can either check the angles. What should the angles always be? The same. Corresponding angles are congruent. So the angles should all be the same, and they are. And the sides are proportional. So what I want you walking away today with is that corresponding angles in similar figures are congruent. Corresponding sides are proportional. Yes or no? Automatically out. Why, Jason? How did you get it so fast? Because the angles are out. You don't even have to check the sides. The minute the angles are different, can't be similar figures.
But, okay.
Yes.
But 5/5 is the same as 5/5, and it's the same as 5
But the angles aren't the same. And I just said similar figures have two rules. The corresponding angles are congruent, and the corresponding sides are proportional.
So it has to be both of them?
Absolutely has to be both of them.
It can't be either one of the angles?
Absolutely, it has to be both of them. Because I just repeated myself. Yes, Ronnie.
So, if the angles are congruent, does that mean that they're similar, or does it have to be just like the angles and sides?
Angles and sides. And you want to check the angles, and normally they don't give you one and the other to check. You just check one or the other. So let's talk about what happens when we're missing a side. Then we're going to get onto our worksheet. So I say, okay, so triangle ABC is similar to XYZ. Triangle ABC, Andrew, watch, is similar to XYZ. So I want to find this missing side. So I begin to look for a proportion I can set up. Gavin?
Wait, what?
Tell me how you raise your hand. Tell me what you're going to say.
I can't remember.
Okay?
I don't.
Jaden?
5/10.
Now, he's exactly right. He could set up 5/10 equal to 12/x. Was there a different way to have solved it that you saw that went faster, Claire?
Whatever one of the lengths are divided by 2 is the one of the smallest.
What is the first rule in solving proportions I want you to look for?
Simplify.
No, the first one. Scale factor. I want you to look for a scale factor. Is there a scale factor?
Yeah.
There is a scale factor that gets you where you need to go.
Times 2.
It's times 2.
4.5.
So then x is 24.
That was
X
easy.
equals 24 without having to do a proportion. Okay? Now let me tell you something. If on a worksheet you're going to use a scale factor, I want to see that you're using a scale factor. Don't just write 24 because I have no idea how you got 24. If you want to use scale, just draw arrows. I'm good with that. Draw arrows and do this.
Can you say that you use scale factor?
You can do that. As long as I know how you solved it. What's the missing x value? Raise your hand. Do not yell it out. Sasha, what'd you get? It is 8. Now, could we have set up a proportion? Sure. I could set up, now I want you to watch this. I could set up a proportion of 6/4. 6/4. Now, what would I have to set that equal to?
12/x.
12/x. As long as I'm picking corresponding parts when I set my proportion up, it works. How do I get from here to here? Times 2 times 2. Watch this. I could also have set up 4/x and set it equal to 7/14. I could have done that.
And then you could have just done 14 times 4 and got the answer divided by 7, right?
Well, or you can follow my rules, which are, is there a way to go left to right from 4 to 7 or 7 to 4? No. What's the second rule? Simplify. This becomes 1/2, and oh, look at that. I can go times 4 to the left.
Oh, I forgot the simple.
Do not forget that second rule, or you will end up doing a lot of cross multiplication that you don't need to do. Because let's be honest, some of us like division, some of us not so much. Yes, ma'am.
Wouldn't it be
No, if it were asking this problem, it's looking for x. You would write x equals 8, and that is your answer.
Okay.
Okay, if it asks you for the scale factor, give me the scale factor. If it asks you for the missing side, find the missing side. Now let's do the last part. Hold. Let's talk about how it really works in real life. So for example, if I had a 6-foot tall adult, and I knew that 6-foot tall adult cast a shadow that is 15 feet long, so 6 foot tall, 15 feet long, then I could figure out the height of a kid if I only have the shadow.
Oh yeah.
Because this is a proportion. This is my x. The height of that kid is my x. So I just go 6 over 15, set it equal to x over 10. Go through all my steps. Well, I don't. You can go left or right, but I'm not going to. Divide by 3 is 2/5 times 2 times 2. Yes, he's 4 feet tall. He's 4 feet tall. So solve that one for me. A palm tree casts a shadow that is 44 feet long.
Okay, yeah.
A 6-foot ladder casts a shadow that is 16 feet long. Estimate the height of the palm tree. Estimate the height of the palm tree. Also good. Shouldn't have to estimate. You should be able to give me the exact number. It is an exact number. It's a terminating decimal. If I do the math right in my head. You know how that works.
Terminating, does that mean
It ends. Terminating decimals ends.
Oh yeah, it is
Oh,
terminating.
then yeah.
Yeah, a terminating decimal, like 14.35, is a terminating decimal if that's the last of the decimal. Terminating decimals just means they end. They don't go on and on and on forever.
Okay. It's terminating.
Shout answer.
Now you want to answer?
Thankfully, they don't know that. Parents can't see the shout answer.
Now you want to answer?
Well, they
No.
can hear you saying it.
What if I want to eat the ladder?
Like the palm tree.
Okay, so someone tell me, some palm trees have coconuts and some don't. I had a lot of operations in Florida, and some do, some don't.
And some are bananas.
And some
Yeah.
less than. But they're good. Okay, someone give me the proportion we should set up right off the bat. Andrew, give me the proportion I should set up to solve.
6 over 16?
That's not a proportion, that's half of it though. What's the other proportion? What are we trying to find?
Palm tree height.
Palm tree. So set this equal to, Cameron?
X over 44.
X over 44. So I start to follow my rules. Is there a way to go from 16 to 44? If there is, I don't see it. So I'm going to go ahead and simplify it. I simplify this to 3 over 8. Now, there is a way to go from 8 to 44. Some of you may say, so I did. Yeah.
5 and 1/2.
Because 8 times 5 gets you 40, so 8 times 5 and a half gets you 44. Now, some of you may not have seen that, and that's okay. If you didn't, then we're going to cross multiply. So 44 times 3, 12, 1 is 13, 132. I'm going to do 132 divided by 8. And I end up with 1, that's 8, that's 52. That would be 6, which is 48. I have 4 left over. I'm going to make that into a fraction just to get rid of it.
Yeah, I got 17 because it's X
Why
over
not?
5.
But really, that's an estimate. That's
Finish.
really, that's the
How I got the answer was different. Well,
That's not how I got the answer anyway. I did times 8.5, and then I did 3 times 8.5, got 16.5. What'd you do?
Well, I got a ruler and decided to measure it on 6.5.
Okay. Claire, what'd you do?
I knew that 6 divided by 3 would equal 2 times 8 equals 16. And so I divided 44.
It's a really small ladder.
You divided 44 by what?
I divided it by 8, and I thought, you divided by 8. It's hard to explain, remember what I
Okay, you're losing.
If it ends in a terminating decimal, do you have to convert it into fractions?
No. Very good question. If you were to tell me x equals 16.5, I'm good with that. Okay? And the estimate thing threw it off a little bit. So here's what we got. We have, yes?
How did you, can you show how you did it on the board with the times 0.85?
Yeah. So, here, we'll back it up. So what he's saying is, how would you have done it with the scale factor? Let me back. Okay, so, once I got this, where this was 3 over 8, and I knew that to get from 8 to 44 was times 5.5, or 5.5. So I just did this times 5.5. So let's get 5.5 times 3, which is 15, carry your 1, 16, the 1 decimal, 16.5.
Oh, yeah, for the extra.
Yeah, I just use the scale factor. But if you don't see a scale factor, some people can see a scale factor that's a decimal, and some people can't. I'm cool either way. You'll find that there are a lot of different ways for you to get the right answer. You just have to pick one. Just go with yours. But always set up your proportion.